Hello, I'm Frank Conkling, and this is Panic Consulting's ArcGIS workshop. And for this workshop, what we're going to do is we're going to look at the parcel fabric, and specifically, we're going to look at how do you find problem parcels in the parcel fabric. Before we do that, I just want to go and remind you that we are Panic Consulting. There's a QR code down here on the bottom right. If you take it there, it takes you to the website and you'll see who we are, what we do, why we do it, and how we do it. Also remind you, Panic Consulting is an ESRI Silver business partner, and we are the first business partner in the nation to get the parcel management specialty designation. Along with, we also have our release ready specialty designation and our state and local government um, designation. So if you are here in the workshop, just to remind you also, any comments you want to have, any questions you want to have asked, go ahead and put them in the chat window. We've got Chris moderating it, and he'll be able to go and make sure that he interrupts me while I'm talking. For those people who are here, we're going to mute you. We're going to ask you to keep all of your webcams turned off, and we'll turn them back on at the end when we're done. All right, let's start. So today's topic, what we're going to do is we're going to talk about finding problem parcels. And what is a problem parcel? It's interesting. Once we get into the parcel fabric, we can redefine what is a problem parcel. Previously, the problem parcel was basically one that either didn't have the correct attribution on it, or we would have to run some topology to find where there were gaps or overlaps or things of that sort. But with the parcel fabric, because we're collecting much more data about the parcel as we're building them and migrating them and such, there's other things we can do. The first is going to be gaps and overlaps. We're going to go and look at that and show you some of the tools inside the parcel fabric that don't require topology. And then there's data mismatches. Let's see if we can find those things where the information that's stored or the the distances that are stored are different from what the shapefile is. Also, the next thing we're going to do is look at line vertices and see where we've got some problems with that in here. And then finally, if you stick around long enough, we'll go and look at consistency check, a way where we can analyze an entire component on there. All right, so let's go ahead and get started. So this is parcel fabric. This is simple parcel fabric. It's got, in this case, just two parcel types. It has the parcels and it has simultaneous conveyances on there. We are starting editing. We've enabled it. And all of these tools that we're going to be looking at today are on the Parcel Fabric Quality tab, Quality Driven Workflows tab. The first thing that we're going to do is how do we find gaps and overlaps? Now, traditionally, we were looking at gaps and overlaps by having to run topology and then running through the topology rules. The problem is that topology actually is changing your data as you're going around. Topology goes through a three-step process. First thing it does is it intersects all features inside the topology. That's called cracking. Then it goes and looks at these vertices that are getting inserted and sees whether or not they're inside a specific area. That's called the cluster tolerance, and that's called clustering. And then it goes and analyzes the rules. But what happens long term is that as you go and run topology and run topology again and again and again, it actually starts creeping and slightly changing the geometry of your data. Now, this is very small, but in the same sense, it still causes problems. So that if you're really interested in seeing and making sure that these things stay where you map them and don't get affected by that, you won't run topologies often. Instead, what you will do is you will use this tool called the Highlight Gaps and Overlaps tools. This Highlight Gaps and Overlap allows you to go and check for gaps without running topology. So in here, if I pull this down, by the way, and this is only parcel fabric, not simple feature classes. So this is again, one of the benefits of being in the parcel fabric. So with the tool here, as I pull it down to set it, we have a maximum width. What this does is this allows you to go and define how wide you want to go and look for them. So in this case, I'm telling you, find gaps and overlaps that are less than 6 foot in width. That way I don't go and see where I might have a road that's not been mapped out or there's no polygon for a road here, and that doesn't come up as an error. It just says, I'll disregard that. I'll just look for smaller ones, and you can set that any one you want. This next option is highlight within each. So this is originally this came out where you had to identify an individual single parcel type, and it would go and look for gaps and overlaps within that single parcel type. With the release of ArcGIS Pro 3.2, I believe it was, they modified this, and now I can actually go and look through all of the different parcel types that are visible at this moment. It will go and analyze whether or not it has a gap or overlap, not just inside the parcel type, but between parcel types. So it's a great way to go and find where you don't have that vertical synchronization that you might look for on here. The other thing is show gaps or overlaps. By default, this thing comes up as a yellow. um, I personally have a problem looking at yellow and seeing yellow for a long time, so I usually tend to set it as red. I know there's red-green color blindness. I don't suffer from it, so I tend to use red as a color. You can set it to whatever setting you want in here. So literally, it's all I have to do. Now what I can do is I can go in here, and when I click on this, it actually goes and analyzes all of the features that are within my display window. Let me go out slightly here and show you there's a dotted area. That goes and signifies the area in which it's going and finding and analyzing. And when I go in here, it's showing me that, again, the gaps are shown in red and the overlaps are shown in green. So if I go in here and look at this, come in here, and if I zoom in close enough, I will begin to see that I probably have on the wrong end of this. Let me go to the other end of this line here, that there's a gap between here. Somewhere in here, there's a gap. I begin to see, there I go. I can see it. There's my gap here between the two. That I have a gap between the adjoiners in here. In this case, this is my parcels. This is my parcels in here. And then I have an overlap here in which these are overlapping on one another. And again, probably should have gone through the middle, but there is an overlap on this also. So the first question is usually, okay, that's good. It goes and tells me it. By the way, all it does is tell it. It goes and displays that this is where you've got a problem. It's up to you to figure out, how am I going to fix this? And there's a couple fixes in here. Some of my favorites. And again, I haven't done an extensive amount of analysis on here, but I can see that I've got a point here and a point here. Perhaps I need to do a merge point. That's one of my first options if I'm going in here and looking to go and fix these. I'll go and do a merge points on here, let it go and merge the points together. I'll then come back out to where I was, and I'll tell it to go and analyze it again. And actually, it didn't seem to fix it. Again, you got to figure out what these issues are when you're going to do this. My other tool that I often use is I'll go in and do an align features. Align features is one which goes and pulls everything that's within the tolerance that I'm creating. In this case, let's go in and create well, we had a 6 foot buffer. Let's go and create a 6 foot tolerance here. And let's go and I'm going to snap to this line. And I'm going to go down. I'm going to snap to this point and to this point here. By the way, I'm going to look at this topology and see what type of topology I have. With align features, this is critical. And I'm going to go in and see, maybe I'll be able to do this without getting a topology graph error in here. I did. So now when I go and check this again, It has fixed these issues. This one is still not fixed. So I might continue and maybe go and fix that. So I'll go in and use this, and I'll often go in and do something like that, and then tell it to align the features in here. There's my topology graph. What is a topology graph? If I have parcel fabric topology turned on, what happens is it says that I tried to get it to do something that would have deleted or collapsed the polygon and such. Often when I'm doing this, I'll often go and say, turn on no topology. Let me draw this because I know there is some issue here. Let me go and draw this to here and to here. And when I have no topology on, it will go and automatically pull them all together. I can highlight and say, go ahead and find anything in here. These are cleaned up now. By the way, notice these are still showing up. I might tell it to go ahead and clear these. So again, one of my favorite tools here is this find here. While I'm here, I might as well go and show you something I've shown a lot of people. Now I'm going to go in here and use align features, not just to go and align features together, but I'm going to use this to remove densified curves. In this case, I know I have a densified curve here and I have overlaps in here. So I'm going to use the curve tool here. And again, I have no topology rules turned on. So this way I can go and correct those. And I'm going to go and tell it to go ahead and align that up. Then what I'm going to do is I'm going to go in here and select everything, but unselect the things that I didn't change. So I basically have left in my selection that densified curve and the points associated with it. If I go to my attributes, it will go and show me I have points, I have parcel lines, I have SimCon lines in here. I'm going to go and delete those. Just delete them out of there. The reason I'm going to do this is I'm going to use, again, the parcel fabric and some of the tools that are in here, and I'm going to tell it to now rebuild my parcel fabric. And what it will do is it will go in here and rebuild these. And I suspect I had some things in here. Let me go back and check my highlighting. And I did have a point here that was still left in there. But what it will do is it will go in the build extent will run the parcel fabric tool to go and rebuild those features that are missing out of my parcel. So it will recreate the lines that are no longer there, that I deleted, the lines and the points. So it will go and repair them. Again, very quickly, no topology. Let's go and get rid of this record just in case. No topology. Go to my Align Features tool. Use that. I'm going to go and draw my path. In this case, I'm going to use the endpoint tool. Snap here, snap here, snap here. Tell it to go ahead and align to there. And then I'm going to select those features. And I'm going to unselect the ones that I modified. So I only have the curve that I want to go and fix. I'm then going to delete that curve. And then I'm going to go back and do a build extent so it goes and rebuilds them. Finally, I'm going to go and highlight it again, and there it is again. We have a question. But I like align features, but it always messes up the curves when they intersect straight lines. Is there a way to preserve the curves? Actually, it's an interesting question. Thank you for asking that. Let me see if I have another one here. It turns out that it's not necessarily just the fact that where the curves intersect the lines, but you have to realize that the aligned features are going to go and attempt to realign all features that are within the tolerance of here, within that tolerance path that I set. So if I go in here and draw this, it's not going to just modify that line, but it's also, there's an intersecting line here. It's going to attempt to bring that intersecting line over to the path that I drew. So you have to be careful when you're using align features. And it has to do with this intersection point here. This is often called, in surveying, this is called a cusp of a curve. So what you want to do is you want to go and make sure that when you draw your line, your path that it's going to go and intersect, if it's a cusp intersection, if it's going to intersect with a point at an angle other than being radial to the curve, you want to make sure that you stop it there and go back along the line. Now, when I go and do this, it will not mess with my line, but what it will do is it will go and fix the curve for me. So again, it's once you get to use the align features tool a couple times, you'll recognize that's actually how you want to use it. It's not just simple as, oh, I can just do that. Again, you can do something like this, and if your tolerance is big enough, here it will start pulling over some things that are inside that tolerance level. Just be careful about that. All right. So that is align or highlight gaps and overlaps, and it will go and highlight the gaps and overlaps in here. All right. So now just sort of go one more time because here's an opportunity for me to go and do this. I have a gap and an overlap here. I'm going to go and fix it so this line here does not have a gap anymore. So I'm going to use this cusp, even though I have a pretty big tolerance here. I'm going to use the cusp to go and align everything into it. I'm going to highlight, and sure enough, it no longer has that gap or overlap there. When you have that cusp, when you have that very sharp angle, again, something less than like 60 degrees, I would consider a cusp. This is a cusp here. This is a cusp here. You want to be careful to make sure you go backwards on it so it doesn't pull those other lines in. All right, let's move on. So that's gaps and overlaps. Um, you use it to go and identify, and once you've got it there, then you can go and determine how you're going to fix it. My go-to tool is usually merge points. If that doesn't fix it, I'll go to my align features, and then I'll make sure to check whether or not I have a topology set or whether it's just going to allow me to pull them all in there. So let's look at the next one then. Distance mismatch. This is one that's really interesting. By the way, let's clear this out. Distance mismatch in that we have the ability with the parcel fabric to begin to do analysis of the lines and the cocoa values associated with those lines. So this tool, when we go in here, is located over, again, on the quality-driven workflows. We go over to parcel layers, and under here is parcel lines. We can do a distance mismatch. And it prompts us and says, what parcel type do we want to do this on? I can tell it to go ahead and do it on parcels, and it will go and create a display layer. This display layer just is used to go and show you where these things are. And when I turn them on, it will go and show me. Here are some lines that the cocoa values on here, the cocoa distance for the display does not match the actual shape length of it. And it will go and show me how far off that is. There's a 2.3 here. There's a 0.91 here. Again, this is a different way of defining whether or not this is a good value, a good parcel, or whether it's a bad parcel, something you want to go and look at. Um, again, you can leave it and it goes and displays all over whether or not there's a mismatch. To go and show you, if I go in here and just look at this parcel, look at this line, here's my lines. And if I look, my distance is 276.21. But if I look at the actual shape length here, it's going to tell me that there is 9/10 of a foot difference between those two. Again, it doesn't fix it for you because it may be that that is not a problem. But what it does is just displays it for you, and there's where you've got areas of mismatch. For example, on this one here, there's 4.5 foot difference between what it says it's supposed to be or what the cocoa value says it should be and what is actually on there. And these display layers actually go and allow you to go and look at multiple things beyond just the distance mismatch. I should show you one of the things I'll often do is it actually creates a selection against your attribute table and pulls it up and says, okay, here's the differences. Here's the tables of all of the line layers in your parcel layer that has mismatches. And if I look here, I've got about 9,000, almost 10,000 of these where there's a mismatch in here between this. Here is my actual COGO value that's stored on here. And over here, because I've moved it over, you'll see where you can actually find the actually, it doesn't show the shape length on here. You need to add that. But it goes and actually shows you what it is. That's what these displays are for. All right. So that's distance mismatch. Similar to that, we have line vertices where we've got lines that are slightly different. Let's go and look under here. I've already loaded these up. Some of these lines, for example, we might have very, very short lines in here. And let's go and see, here's some of the short lines. In this case, when I go and display my short lines, I've got in here a very, very short line in here. And if I look, I've got a bunch of short lines. I've got extra points in here. And this is pointing out to me, again, at a very precise level, at a very granular level. Here's a problem. And again, I did not do a gap and overlap here, but it would go and display this. So this is another way for me to find where I've got some problems. And in this case, I'm just going to go and do merge points on here. And I'm going to tell it to go to merge to point number 1. If I click on point number 1, it's going to show me where it is. Here's point number 2, which is a little bit further. And note one of the things it does is it goes and shows me what the features that are associated or related to that point are going to look like. Here's point number 3, and it will show me what these are going to be. I'm going to leave it at point number 1 and tell it to go ahead and merge these. And it will go and merge them and clean that up for me. Interestingly, the merge points, and this is, you want to be careful with this, merge points, I found out recently from Esri, it's not sort of the normal parcel fabric component in here. Merge points immediately goes and deletes anything that you're not going to go and have it move to, and then goes and redefines everything that's associated with. So let's go in and just show you one of those things. If I go in here and get to a control point here, and I'm just going to really mess this thing up just to show you one of the challenges is that merge points would actually let me go and move everything to here, which is not a bad thing. Perhaps that's where it should be. But if I tell it to merge the control point here, first thing it does is it deletes that other point. It deletes the control point and this makes it disappear. Be careful with merge points because it acts a little bit differently than the standard parcel fabric on here. I've talked to Esri about it. They're going to try to see if there's a way to fix that, but it's because of the way the underlying algorithm is working. It doesn't look to see is that a point that's defined that shouldn't be shown. Anyway, those are two short parcels. And let's go in here and look. In here, the two short parcels have a definition query which says if the shape length is less than 1/2 of a foot, and it's a current parcel, go ahead and show it to me. You can also go and tell it to also do shade length on both current and historic parcels on here if you want to go and do that. All right, do we have any questions yet on these? Oh, here's another too short that we have here. I've got it being displayed. And this is interesting because this entire bulge right here is less than a 600th of a foot in length, which to me means that's probably a bad little thing. That might be something that was caused previously. I don't know. And in surveying for 40 years, I've never seen anyone that goes and defines a length of a line as 600ths of a foot. So this probably deserves to be straightened out. The normal type of thinking would be, oh, let's go and do an aligned features or something like that. This is 600ths of a foot. This is tiny. Again, my go-to tool is merge parcel points. So I'm going to go in here and I'll go and say, yeah, merge them into, I want to disrupt it less. So I'm going to go to one and tell it to go ahead and merge everything into one. It will pull two over. We'll take three, move it over here, there, and clean this all up for me. All right. So again, first you identify them using some of the tools. Then you go in and you figure out what you want to go to do and clean them with. Again, I tend to use merge points, and then I'll go and look at aligned features as my second option on here. All right, we got one more thing here that we're going to look at. This is consistency check. This is this is a very interesting thing on here. I'm going to go to consistency check. This is a subdivision. Now, this subdivision, we actually have a record here. This record, let's go and say select everything associated with this record. And it's going to go and find me the distance mismatches. Let's go and turn those off. We don't need those here. Let's go and unselect these. And it's going to show us connection lines. I don't have my collection lines turned on. Let's turn them on. It's going to also show me the parcel line mismatches. Those are extra. We don't need those in here. Here's our parcel lines. Here's our parcels. Here's our historic parcel lines, which it's telling me are not turned on at the moment. Let's turn them on. All right. Here's my historic parcels. Here's my SIMCON layers. Here's my SIMCON on here. Now, what the consistency check does is it basically goes and analyzes the bearings and the distances associated with these features that are on here. So the bearing and distances on the lines, looks at the polygons, looks at everything that's in here, and performs a least squares adjustment without any control points. So it basically is just looking to see whether or not the information that's stored on this subdivision is consistent within itself. So it doesn't require control points. It just says you've got to have something that's related to one another. And when I do that, this consistency check here will pop up a dialog box. All right, it actually says I've got some edits here. All right, let's go and save those. Now in here, this is where there's some interesting things here. I know I've got some problems with this subdivision, only because I've gone through it before. And right now, 0.05 meters is too small an indication. I'm going to go and tell it, just look at international feet, and maybe 15 feet is good enough. And let's see whether or not we have any inconsistencies in here. It will go and give you back a dialog box. That dialog box will tell you what your consistencies are in here. And in this case, tells me that this is inside of this. The air is high. It gives me a recommendation to maybe go and lower it a little bit. That's all I needed to do. All right. But what it does is it goes and creates a series of layers. It creates one called adjustment vectors. These adjustment vectors say that if in fact you would apply this entire process against here, this is how those points would move. And then what points are actually going to get moved, and then what lines are going to get moved and how are they going to get adjusted. So it's going to show me that I have some inconsistencies in here. Those inconsistencies might be bad bearings, might be bad distances. It could be several different things on here, but there is something wrong. To me, this means, okay, let's go back and check and see what's going on with this. I unfortunately don't have the plat here. This was a client's um, here, but it will go, and in this case, it's showing me that these points are going to move over to here. This point is going to move over to here. So it's going to go and give you information about what sort of adjustments are going to happen here. And this is 2-foot adjustment in here. So again, when I look at this, I use this primarily just to go and see if I can identify where there might be problems with my lines. What lines are going to get moved? How much are they going to get moved? That sort of thing. All right. Can I apply this? Let's go and look at this same thing here. This is going to give me an error, by the way. I'm just going to do it on here. No parcel fabric points were updated. All right, because I had no control points in here. This consistency check is not to go and apply an adjustment. A consistency check is to go and check to see if anything has to be moved because of what you have applied here. Let's do a little analysis. Let's see if we can find here. In this case, this is already telling us we have differences in our distance by about 1/10 of a foot here as far as how big it's supposed to be and what's actually being shown here. Those are direction points. So if I look at the lines, I actually can see that there was, all right, there was no rotation, no scaling put in here when it was applied. 98.54. This actually doesn't look bad here, but there's some difference in here that won't, says it's not supposed to go and be that. All right. That's all I've got for today. Do we have any questions on here?
We don't have any in the chat currently.
Okay, let's go. Any other questions? Otherwise, we might stop this early. None being, I hope you enjoyed this. It was short, but hopefully you got something out of it. If you're here right now live, stick around. We'll go and talk more. All right. Thank you.